So now let's look at the DQ. So DQ and the Q actually are similar. It is not DEQUE. That actually is a function in Q. This one is DQ, but there is no UE. This actually is a double Q, double NDQ. DQ is a double NDQ. So it's a stack plus a Q. So you can remove and add from both ends, the rear and front. You both can do DQ and Q. So functional wise, there's no difference. It's a combination of stack. So stack basically, you actually push and pop from this direction, right? Q, you push here, pop here, right? DQ is that you can push and pop from here, push and pop from here. Okay, so this one's called DQ. The last one DQ. This one's a Q. This one's a stack. So performance-wise, DQ can use to replace both stack and Q because it's more flexible. Is that okay, Eric?
Yeah.
But it's nothing special, so that's why this part is not that long. So a DQ is known as double NDQ. It's an ordered collection of items similar to Q. It has two ends, front and rear, and an item remain positioned in the queue. What makes the DQ different is that the unrestricted nature of adding and removing item from both ends. New item can be added at either front or rear. Likewise, existing item can be removed from either end. In a sense, the hybrid linear structure provides all capability of stack and queue. So stack and queue can all be used, can all be implemented by DQ. And DQ actually has a feature for both stack and queue. It is important to note that even though DQ can assume many of the characteristics of the stack and queue, it does not require LIFO or FIFO ordering that are enforced by those data structure. It's up to you to make consistent use of addition and removal operation. So you have the capability, but you don't need to do LIFO, last in, first out, or first in, last out. That's up to you. You can do whatever you want to do. So it's just give you more flexibility. So it's something that is you can do both ends. So the function, you have DQ, we have add from, add rear, remove from, remove rear. It's empty, you have size. So that's simple. So here is an example. You create a empty list, add to the rear for 4, add to the rear for dog, add to the front for cat, add to the front with 2, and then check the size, check the emptiness, add the rear with 8.4, and the rear is 8.4 here, and then remove from the rear, the 8.4 got taken out, and then remove from front, the 2 will be taken out. So that's not hard. Implementing the DQ in Python, so it's just another using a list will be fine. But you need to do pop 0 that actually is removed from 0 location, and you also need to have the insert 0 for add to the rear. Okay, so here you have more function. Here you have add from that will append to the end. Okay, insert add rear, you insert at the 0 location. Remove from, you will pop. Remove rear, you will pop 0. Okay, so that's the only thing you need to know. So you have DQ checking if it is a empty one. Initially, it will be empty. Okay, and then add 4, add dog, add cat, add 2 to rear or front. So you will end up with 2 cat and then 4 dog. Okay, from front to the rear. And then you remove from rear, you get 8.4, and remove from front, you get 2. Okay. So implementing DQ in Python, you can see many similarity to Python code already described for stack and queue. You are also likely to observe in this implementation, adding and removal bin item from the front is order of 1. So this is discussable. You just know that adding to the front is always or removal from 1 is always order 1. But to the rear, you need to actually push out those data. And the list, if it is implemented not by linked list, but by array, it will be order of n. But if it is actually the linked list for this list, it will not have the order n. It will still be order of 1. Okay? So what is DQ? Let's check the palindrome checking. The palindrome checking is like you need to do palindrome. So what is a palindrome? Palindrome is a string. So Larry, is that okay?
Yeah.
So palindrome is some word like mom is a palindrome. Race car is a palindrome. I'm sorry. So race car is a palindrome. So you remove one, checking with this one, remove one, checking with this one, remove one, checking with this one, remove one, checking with this one. If they are the same, then it's a palindrome until it's all empty, or only one letter left. Then you can check using the DQ to check whether it's a palindrome or not. So since we can remove from both ends directly, so we can compare them and continue only if they match. Okay, if there is no match, then it's not good. So each time we get part one from front, part one from rear, and then if that match, then that's it. If no, we keep popping from both ends, checking if there is a discrepancy, then it's not a palindrome. Or if there is only one character left, then that is actually a palindrome already. So that we use that to check that. So let's look at the code. So basically, we got a string, right? And then we use that string. We actually enqueue, create a character DQ, okay? And then we put every word, a character into the character DQ. Okay, so we create a equal to be true, and then we start as long as the DQ is size greater than 1 and the still equal, then we continue. So we from the front and rear get 2 characters out and then compare them. Okay, and if they are equal, then it's fine. If they are not equal, then we will break and saying that it's not a palindrome. Otherwise, we'll keep doing that until we finish the whole program. And if nothing changed for the it's still equal, the still equal will have the true value and will return with the palindrome checker to be true. Okay, so the first one is not palindrome. Second one, radar is a palindrome. Okay, that's it for DQ and Q. And hopefully you enjoyed it, and let me know if you have any question. Okay, and this part is not hard, so I run it a little bit quick. And the only thing is that when you analyze a problem, you need to be able to map problem into a Q or DQ. And it's first in, first out, something like that, okay?
Okay.
And next time I'll go into the prioritized list. Okay, but we need to finish those conversion from linked list to generic linked list, okay?
Mm-hmm.
Okay, thank you now. Bye now.
Bye.